Alright, so this chunk of work extends your integration skills into questions where you can deal with algebraic fractions which you can split into partial fractions. But before we do that, it's worth refreshing our memory as to how to use some C3 skills when integrating. And you were probably taught substitution to integrate something like this. And what you're looking for is to see if part of the expression on the denominator, if differentiated, will give you something that will cancel with the variable that's on the numerator. And I can see here that if I differentiate 2x plus 5, it will give me 2x. That's an x term, which means that that should cancel. So what we do is we say let u equal x squared plus 5. We differentiate that, so we would differentiate in u with respect to x, and that gives us 2x. Now I'm going to be replacing the x squared plus 5 with a u variable, which means I don't want then to be integrating with respect to x. I want to be integrating with respect to u. So what we do is we treat this as if it's a fraction and rearrange it to give ourselves dx equals. So if I do that, I'll end up with du over 2x equals dx. So coming back now to my integral will now have an x over the square root of, and instead of x squared plus 5, u, and instead of writing dx, I'm going to write du over 2x, and there you'll see that what happens is that extra x variable cancels, and I can then write that, I can take out the half as a constant, I can write 1 over u square root of u as u to the minus a half du. Straightforward integral now. Add 1 to the power, you get a half. You divide by the half, you get 2. 2's cancel, and I can now, instead of having it in terms of u, I know that u is x squared plus 5 to the power of a half, and there are no limits, so I need to include a constant of integration in that. Okay.